useState is the first hook you ever learn in React. As you get more comfortable with React and start building out more complex components, you might have 5 useStates in a single component, or 10, or hell, even 15. Before you know it, every time you click a single button in your component, you're re-rendering everything 25 times. It starts getting way out of hand, and then you add images or graphics, or anything kind of computationally intensive, and suddenly your page is stuttering and lagging all over the place. Something that I don't think is taught very well is that useState is not the only hook for storing persistent values in your components. useRef is a very underutilized hook that stores persistent values, just like useState, that is way more performant. useState and useRef are both hooks for storing values, but 90% of people just spam useState everywhere they see, and useRef tends to get ignored. In this video, in the simplest way possible, I will explain the difference between useState and useRef and exactly when to be using each one, as they both have their own distinct use cases. The first section will be fairly brief, and if you stick around to the end, I'll walk you through some real examples on when to use useState versus when to use useRef. Here's a code snippet that is almost always used as the introduction to the useState hook. We set up a state called count with a setter function of setCount, and we default that count to 0. Every time we click this button right here, count increments itself by 1. Our React app sees that we called a state setter function, like setCount, re-renders this component, and now our page is showing the incremented value of count. I can go over here and show you that. If I go click increment, you can see each time I click, the count updates and visually updates on the page. Pretty simple, right? But let's now take this very beginner concept and apply it to a ref using the useRef hook. Instead of doing count and setCount and defaulting that state to 0, let's instead use a ref. I'm going to make a new variable. I'm going to call it countRef, going to be equal to useRef, and it will also default to 0. And we'll make sure we get useRef imported from React. Now anywhere where we're using counts in here, we need to replace it with countRef. So we'll say countRef.current, and then this one, instead of calling a state setter function, we will just say countRef.current plus equals 1. Remember that all refs are just an object with a current property, which is why we use this syntax. If I go ahead and save this and make sure this page is refreshed over here, and I start clicking increment, watch what happens. I'm spam clicking as fast as I can right now. No matter how much I click, the page never actually updates. If I go over to the code and I just log out the ref, like I say console.log countRef.current, and I go ahead and save it, go over here and open up the DevTools, refresh it, you'll see it says 0 and 0 right here. But notice, every single time I click, we're never logging this out ever again. It's only logging it out on the very first render. What that indicates is that this code in your component right here, where we're doing the console log, is never running again after the initial render. This is the first and primary difference between useState and useRef. State changes, like having a piece of state called count and setCount like this, are going to trigger re-renders in your components via this setCount. Ref changes, like when we're just incrementing ref like this, will not. What this means in actuality is that no matter how much a ref changes, it will never cause any component to ever re-render. I could click this increment button right here 5 trillion times and the component wouldn't even re-render once. And this is because when you modify a ref, like we are doing on this line right here, you are directly modifying a value that has nothing to do with the React state system. React sees that you're modifying a ref and says, cool, but we don't care. The only reason why calling a setter function with state, like something like setCount here, works to re-render the entire page is because setter functions from useState are hooked directly into the state system and are treated specially. Calling a state setter function is your direct way of telling React that your component needs to re-render to have updated state. This distinction might seem incredibly simple, but it's important for a couple of reasons. First of all, this implies that refs live outside of React's rendering cycle. Inside, you have many hooks like useState, useEffect, useMemo, but React does not care when a ref changes, meaning it lives completely outside of the state system. Given that information and knowing that useState and useRef are both used to store values, we can deduce that refs are basically a useState that just don't trigger re-renders. So aside from the main concept of useState causing re-renders and useRef not causing re-renders, what else is similar or different between these two hooks? Well, for starters, both useState and useRef will persist through re-renders. What I mean by that is if I again use a ref for our counting example and I click the button a couple of times, obviously it doesn't re-render. However, if I manually force a re-render by toggling some actual piece of state with this toggle me button like this, now it'll actually show how many times I've clicked this button. But no matter how many times I force re-renders by clicking this toggle me button, the ref always stays at the same number that I left it at, which is 5. Again, I can spam click this button, then toggle the state, and now it updates because we've manually forced a re-render. Keep in mind that whenever we re-render a component, that means all the code inside the component is rerunning again. And yet my ref here didn't lose its value. It's still what it was before, despite the fact that I'm re-rendering the page over and over again. It persists through re-renders, meaning no amount of useState or anything changing will cause a ref to go back to its initial value, in our case 0. Only a hard remount like a refresh of the page, like this, would cause that to happen. With useState, you know that it also persists, so both useState and useRef persist. The primary difference between keeping a value in a ref like we're doing with count here versus in just a regular variable, like if we were to do let count equal 0, and then in here we just said count plus equals 1, and then we just put that here. Let's say that's all we did, and then we save it, go over to this page here, we click increment, and it's not visually incrementing on the page because, again, just like useRef, regular variables like this are not stateful, so they won't trigger re-renders. The difference is now in this case, if I increment this 100 times and get it to a super high number, and then I click toggle me to manually re-render this component, count is still going to be 0 because each time I re-render the component, this will actually get reset back to 0. With using a ref, it will never get reset back to its starting value unless, like I said, you do a hard reload. In summary, regular variables do not persist through re-renders ever, but useState and useRef will both persist. The next biggest difference between useState and useRef, aside from causing re-renders versus not causing re-renders, is that a useRef value cannot be used in any sort of dependency array. Whether that's useEffect, useMemo, useCallback, it doesn't matter. Refs in a dependency array do nothing. So for example, if I have a useState count like this, and I also have a useEffect that just alerts that we're running the useEffect, and then I put count in the dependency array, and I go over to our page, each time that I click increment, we're going to alert that we're running this useEffect. Every single time that it changes, this is going to run. On the flip side, if I swap out the state with a ref, logically you might think that having countRef in the dependency array of this useEffect would still cause it to run each time the ref changes. But if I go over to our page here, click increment, I'm spamming these clicks, and notice how we're never ever alerting anything. So it does not matter that we have a ref in the dependency array. Refs are still by nature not reactive, so having the ref in the dependency array does nothing. It's about as effective as just keeping the dependency array completely empty. That's not to say that you can't have refs inside of a useEffect or useMemo or whatever else. For example, if I needed to log out the ref here, I could just do something like, countref.current, and having this here is fine. Just know that putting a ref in the dependency array like this is not going to make any sort of difference. It's the same as not putting it there at all because, again, it's not reactive. One other difference between useState and useRef is that a useState setter function cannot be called in the main body of a component. For example, if I tried to call setCount just like this out in the open, we know that's just going to cause an infinite loop, so we cannot do this. However, if I wanted to call countref.current plus equals 1 out in the body like this for whatever reason, that's perfectly fine. We're not going to get any problems with this. Not that you're going to be doing this often or anything, but this is a tool you could use if you want to count how many times your component is re-rendering. Since refs always persist, if you wanted to manually track how many re-renders you have for whatever reason, you can do it in a ref like this, just in the main body of the component. The last main difference that I want to talk about is that updating a state with a setter function is asynchronous versus changing a ref, which is synchronous. For example, if I have this handle click function that gets called each time we click a button, and I try to set the count with something like this, and then immediately after, I try and print off whatever this new value is going to be. This is actually going to be the old value because whenever we call a state setter function like setCount, it doesn't happen right away. It actually queues it up for a re-render, and then once React sees fit, then it will actually re-render. So this value here will be old. This doesn't happen immediately. However, on the flip side, if I use a ref, this does actually happen synchronously. So I could update the value just like this, and then immediately after console log it out, and it would be the updated and correct value. Refs update right away, React state does not. Now there's a few more nitpicky differences between state and refs, but instead of going over every single fine detail for the next 20 minutes, I want to instead go over some examples with you all, where we'll be presented with a problem, and we have to figure out whether to use useState or useRef or a combination of both. We have a page here that has a current price and a previous price, both of which are loaded up in React state right here. Current price always just starts at 10, and previous price will always just start at whatever the current price is. We have this change price button right here that we can click, and it will randomly pick a new price. It will set the previous price to whatever the current price is, and then it sets the current price to a random number. If I go over here and start clicking it, you can see it randomizes the current price, and it sets the previous price to what the current price just was. So the current price is $5. If I change price, Notice how we go to 22, but now the previous price says $5, so we can see that was an increase of 17. That's really all we're doing. We're just keeping track of the current price and the previous price, and then at the bottom here, we're just finding the difference between the two of them, so whether we went up or we went down, and by how much. I want to divert your attention to this change price function right here. Notice we just have two React setter functions being called inside of here. This means that every single time we click and we activate this change price function, we're going to re-render the whole component twice, once for the previous price and once for the current price. Now I want you to look at this previous price right here, and I'll ask you this. Does previous price need to be stateful, or can it be a ref? You decide. If you said that it needs to be stateful since it displays on the page right here, you would actually be wrong. This previous price right here can actually be a ref instead of a state. Having it as a state is causing unnecessary re-renders that could slow our page down. Now obviously in this example we don't have that much going on, but if the complexity was higher, this could actually slow performance down because you're re-rendering when you don't need to be. Now I know what you're thinking. This previous price obviously needs to be a state because it's actually displaying on our page over here in real time, and it helps determine our change, whether it's positive or negative, and whether we show this up arrow or down arrow. Therefore it's visual, which makes it a good use case for state, and by itself you would be correct. However, remember that the problem with refs is that by themselves, they cannot cause re-renders. However, if we are calling a state setter function like current price right here, we are already guaranteed to re-render. So why cause two re-renders with two setter functions when you only have to re-render once? What I mean by that is we could convert previous price to a ref just like this, where instead of using any sort of state or setter functions, we're just using a ref and manually changing the ref value. Lo and behold, if I go over here to our page and I start changing the price, notice how the previous price and the increase decrease is changing in the exact same way that it was before. We're showing the current price, which is stateful, the previous price, which technically is not stateful, and the increase decrease, and it's still working exactly as we intend it to. This is a bit of an advanced and nuanced thing with state and refs, but if you have multiple things that are changing at the exact same time, for instance the previous price and current price, which are both happening within this change price function, then only one of them actually has to be stateful if you have a simple scenario like this. And it actually doesn't matter whether previous price or current price is the one that's stateful or not. As long as one of them is stateful and will trigger a re-render, the other one doesn't have to be because it will already guarantee to be re-rendered. I want you to imagine the visual that we had earlier of refs existing outside the state machine of the other hooks. A ref always lives outside. However, if it's chained to a useState value, like it is in this case within this change price function, it will be stateful in a way, without actually being state and causing unnecessary re-renders. Let's go back to our example using just state for a second. Let's say instead of having 2 pieces of state, we actually have 6 pieces of state, and we're setting all those in the exact same function. This means that every single time we click this button, we're actually re-rendering this page 6 times. And this is the way that I see most people actually handle this, but they all change effectively at the exact same time because they're all called in the same function. Therefore, we only actually have to re-render once. So as long as just one of these is stateful, the others can all be refs, just like this. It will still behave in the exact same way, but we're re-rendering the page 5 less times on every single click. It's these kind of optimizations that are going to be negligible if your app is super tiny or small and just not very complex, but it's best to get in the habit of writing clean code just like this. That way, at a real job or when working on a larger scale or more complex React app, you don't slow down the performance of the page because you're writing inefficient code. I actually had this exact thing happen to me at my job. We were basically making a game on a page where you'd have to unscramble words given a bunch of different letter graphics. And we actually had functions that looked something like this, with a bunch of different random states that were all getting set at the exact same time. And basically any time the user did literally anything on the page, we would re-render the page 5 or 6 times. And these letters that we were unscrambling had graphics and animations on them, so we were loading quite a bit of stuff on the page, and every single time the user did something, we would literally re-render the page 5 or 6 times for zero reason at all, when it only had to be re-rendered once. I went in, changed a lot of them to refs, and it actually worked much faster, speeding up the page by a considerable amount. It's very important to mention that using refs just like this is very context dependent. Obviously, your component could be more complex, and maybe one of these refs here, like current price 2, actually needs to be used somewhere else in the component, and that requires it to be stateful. That's perfectly fine if it needs to be a state, but I'm more than willing to bet that you or someone you know, just spam state setter functions like this in a situation where you don't even need all of these to be state. If that's you, I beg you, please use refs instead because they are more performant and the code is just cleaner. The next example that I want to walk through with you is a super bare bones, super basic login page in our React app. And when I say bare bones, I mean that all we have here is just an input for username and an input for a password. Once we enter these, we click this login button, and we assume this login button will do some sort of authentication. For the sake of this example, we'll assume that if we want to authenticate, that in our handle submit function here, which is called when we click the login button, that we're going to need access to the username and password to send to some backend or authentication service. I can tell you with certainty that the vast majority of people in this scenario, if constrained to just vanilla React, would handle this login page just like this, where you have a piece of state for each login field. So we have a username state and we also have a password state. And then in the on change of each one, we just set it to whatever the current string is in that field. And then the submit function simply just grabs that state and then we assume submits it to the backend. This works just as you would expect it to, but I want you to ask yourself, should I actually be using state here? The answer is no. Using state is not optimal in this scenario. Why? Remember that state causes React to re-render. Refs do not. If I throw a console log here in our component that just says re-render, and I go ahead and open up our console over here, and I go into one of these fields and just start typing, notice every single letter that I click in this input field is going to just do another re-render. However, if we have a scenario like this where it's just very bare bones login page, there is zero reason for this page to actually be re-rendering because there's nothing reactive actually happening. Whether we re-render 10,000 times or zero, this page is going to have the exact same functionality, so why re-render at all? You might think that these input fields changing needs to re-render my page so that the input always stays in sync with React so we can have the updated value in the handle submit function. However, you'd be wrong because nothing about these inputs is actually stateful. The characters that I type in here that show up on the screen are just stored in the actual semantic HTML input. So whether or not I make some state to keep track of each one is irrelevant to the visual updating of the page, because again, these are just stored in the HTML. What I'm trying to say is in this case, we should not be using state, but rather we should make these refs instead. If I replace each of these states with a useRef like I just did right here, and then I go down here and look at our onChange, and I'm instead just setting the ref value instead of calling a state setter function for both the username and the password. And then in the handle submit, I'm just getting username and password from both those refs and using that, then it's going to behave the exact same way without the unnecessary re-renders. For example, if I go ahead and make sure this is saved, open up our console here, you can see as I type in this field here, I'm never getting a re-render in the console. You can see I'm typing, it's never re-rendering, but it's behaving the exact same way like it was before. And we know that refs are a persistent value, so the username and password in here are going to be the updated refs. These aren't going to be some out-of-date value or something, just because they're refs. Once we call handle submit, this will have the updated value of each field, but we've just gotten rid of the unnecessary overhead of re-rendering every single time we change a single letter. However, setting refs just like this, like we're doing right here, is a little bit goofy because there's a much simpler and more efficient way with still using refs. So instead of having these store the actual string inputs, what you could actually do is just make them store HTML input element, just like this. We can say that or null. We can do like this. We can actually get rid of this onChange entirely, and we can literally just smack it on here with the actual ref. After all, this is what refs are actually for. Let's say username ref for this one, and this one would just be password ref, just like this. And then in our handle submit function, we could literally just say .value for each of these. And now it would have access to the exact same value, and that's how you technically do it with refs while still maintaining the same functionality. I can now prove to you that this login function, this handle submit function right here, will behave exactly the same way as state. If I go ahead and save this, go over to our console here, for username, I'll make a little more room for this. I'll type in ABC, and for password, I'll type in XYZ. Go ahead and click login. You can see we're submitting with ABC and XYZ. If I change the password a bunch to be ZZZ and a bunch of them, log in, we still have the updated value here in the console. You can't see it. I can zoom in here a little bit. Not exactly the ideal view. You can see we have the username and password, again, updating synchronously as I click login. So long story short, we have perfect functionality for doing a very bare bones, very basic login page without using state and without re-rendering our page over and over again for no reason at all. In terms of functionality, this is likely the cleanest way that we could actually do this, using refs over state. I want to move on to our last and final example using this exact code that we've already set up with the addition of a couple of things. We decided that using refs is the cleanest and most efficient way of handling this login page for this particular scenario. Let's say we want to add some more functionality though, to make it not so bare bones. If both fields aren't filled out, meaning at least one of them is empty, don't even let the users click this login button and gray it out so that this is apparent to the user that it's not clickable. An easy way that we might do this is to make a variable called both fields filled, just like this, that just checks the length of each ref to see if it actually is anything. If it's 0 or if it's null, we know the string isn't actually filled out yet. We're basically checking these booleans. We're saying, okay, are both of these true? If both username and password are actual strings like ABC and XYZ, this is going to be true. Otherwise, it's going to be false. And then in our JSX for our actual login button right here, we can basically just do an easy conditional style using CLSX. And we can say that by default, we're going to make the login button gray and make sure it gets no pointer events so it's not even clickable. However, if both fields filled is true, then we can say the background can be green and we actually do have the pointer events back so it is clickable. Cool, so this conditional logic right here seems super sound, right? This boolean will simply tell us if both fields are actually filled out, and if they are, the button's green and clickable. But now I'm going to show you a problem with using refs. If I go over to my page now and I type in AAA, BBB, or even just the ABC XYZ we had before, notice how the login button just remains gray and I can't click on it. No matter what I do, it never turns to green or becomes clickable. And this is exactly the scenario where refs are going to fall short when compared to state. Why is that? Because we're not re-rendering whenever the ref changes, this condition right here, this both fields filled, is never going to actually recompute. It starts out as false when the component first mounts, and no amount of refs changing will ever get this to actually reevaluate to anything. The result is, if it never reevaluates, then this conditional style can never actually turn true, so it always stays gray and unclickable. In our earlier scenario, with just the username and password and nothing else, we had zero need for anything to visually update on the screen, and using state was wasteful. Now in this case, we need this both fields filled condition to recompute whenever something changes, which actually does require a re-render. Therefore, if we want this condition right here in the functionality we just talked about of graying this out, we need to use state. If we're going to do this using state, it would look something like this, where we have our use states back. We have just our username and password being accessed directly here. Both fields filled is just looking at those pieces of state. And then we bring back the on change, where every single time we change one of the letters or something, we're going to call that state setter function. So now if I go and save our page, you can see how it's going to behave differently. If I type ABC, it's still gray, but as soon as I type something in the password field like XYZ, notice how it turns green and now the button is clickable. Again, I can go back. Now they're both not filled out, so it's gray. Now something's here and it's green. So now it's reactive because state is inevitably part of the React state system. The main difference between our two scenarios is that in this scenario, something actually needs to visually update on the screen or actually change with some user interactivity, like being able to click this button here, meaning we need the page to be reactive. useState is reactive, useRef is not. Therefore, in this case, we need to use useState. And with that, we're actually going to wrap up this video. I hope this video gave you a better understanding of when it is appropriate to use the useState hook versus when it's appropriate to use the useRef hook. After watching this, you should hopefully be able to differentiate their use cases and find times now to use useRef instead of just spamming useState everywhere. Take care everyone, and I'll see you in the next one.